Hello everyone, welcome to my channel Code with Sunny, and today I am going to discuss the problem interesting names of April Easy 2021 of Hacker Earth. Okay, so let's discuss the problem now. In this problem you can see there is a person Ben which is obsessed with names, so he only likes to build up a string which is of length n and it doesn't contain any palindrome substrings of even length. Note that he doesn't want to a substring any of the substring to be of even length and it is of palindrome, then it is not allowed in his name. Okay, and the name can consist of lowercase alphabets, and we have to determine what will be the total number of interesting names that Ben can build up, and this number can be very large. Compute it modulo this number. This is a prime. Okay, and there's a definition of palindrome is given, and for each test case you can easily see I will be having like n, which would be the desired length of the string that Ben wants, and for the output format we have to print the answer for every test case modulo this prime number. Okay, so basically we have to not build such a string which contains an even length substring and it is of palindrome. Okay, so how we are going to do this problem and what should be the best way to solve that? Let's move further to analyze in detail. Okay, you can see I am going to just explain in a reverse manner. That is, we are not allowed to build any palindrome substrings of even length. So first let's try to understand this in reverse manner by taking a palindrome string of even length like ABC C B A. Okay, so this is a palindrome string of n equal to 6. Now let's first determine what is happening here. You can see if this is a palindrome, this character must be matching with this character, and this character must be matching with this character, and if this character also matches with this character, so it is easily observed that if S1, S2 and S3 and similarly it goes up to S6, if these are the characters of a palindrome string of even length and if this entire string is a palindrome, then it is obvious that the substring from S2 to S5 will also be palindrome, and from S3 to S4 will also be palindrome, and we will have been like it is a middle one, and exactly S3 matches with S4, and we arrived at conclusion that if we have a palindrome substring of length 2 in my string, then it is always we can always build up a palindrome string of greater length, that is n greater than 2. Okay, because you can easily see here we have n equal to 2, that is S3 matches with S4 and it is a palindrome string. And if it is a palindrome string, I can build up for length equal to 4, that is I can build S2 exactly equal to S5 and it will be palindrome of n equal to 4. So I will arrive at conclusion that if there is a palindrome string of length greater than 2, that is n equal to 4, 6, 8 or 10, then there must be a palindrome string of length n equal to 2 and 4 and 6. If there is a palindrome string of length n equal to 10, then we will have all these satisfying that. Okay, so what is with the minimum length? Minimum length is 2. Then we should, if we are going to avoid this minimum length, that is if we are not if I am going to just eliminate this palindrome string of length 2, then we can never form the palindrome string of even length greater than 2, that is 4, 6, 8 or 10, obviously. So we will be just eliminating that, we will be just focusing on, we are not going to build the palindrome string of even length. Okay, so what should be the best way to solve that? You can see I will have a n characters. You can see S1, S2, S3 and it goes up to Sn, and it means that we are not going to have like S3. S3 should never be equal to S4, or you can also say Si should never be equal to Si plus 1. How this can be possible? There are 26 characters. So what is the number of ways to choose the first character? You can see if number of ways to choose the first character is exactly equal to. Okay, so let me raise this up. It is really annoying. Okay, so what is the number of ways to build up the first character? So number of ways to build up the first character is exactly equal to 26. Okay, and what is the number of ways? Okay, so let me choose this one. Oh, okay. Okay, so okay. So what is the number of ways to build the exactly first choose the exactly first character? It would be like 26. And what would be the number of ways to choose exactly second character if we want si not equal to si plus 1? It would be simply 26 into 25, because si plus 1 should not be equal to si. And if this is happening, what should be the number of ways to choose next character? It should be like 25 also, because I'm not going to choose that character which is already present at this position. So it would be again 25, and it's so it goes on like 25 to the last character. So what should be our answer? Our answer should be 26 into 25 raised to the power n minus 1. Okay, so let's head over to the code to see the implementation. Okay, so you can see I have here a binary exponentiation. You can say to calculate some power of a given number in log of min of a comma b, that calculates the power efficiently. If you are not aware of this function, then I will recommend to check the description for the binary exponentiation tutorial. Okay, that calculates the power of a given number efficiently. Okay, now you can see for every test case I have given n, and I am going to just calculate 25 raised to the power n minus 1, and you can see n is going to like 10 power 5. So I need to calculate this power efficiently and with modulus, because it is going to be overflowed. So I need to have a binary exponentiation method that is going to calculate the power of a given number very much efficiently. Now our answer would be 26 into this term, and with modulus, and finally print the answer. Let us submit this code and check it out if this is going to work fine or not. Yes, it is good. So if you have any doubts, let me know in the comment section, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.